In energy production, prediction is a warning, but a warning alone doesn't turn a valve or shut down a well. If a system can forecast an impending disaster but lacks the capacity to physically intervene, the outcome of that crisis remains the same. In high-pressure industrial environments, the gap between identifying a problem and acting on it is a zone of extreme risk. A delay of mere seconds in this space can lead to massive financial losses or the total failure of critical infrastructure. To close this gap, OmniPetro utilizes a specific architectural layer designed to turn digital signals into physical movement. This is the decision engine. By connecting these insights to immediate execution, OmniPetro moves beyond simple forecasting to become a system with the operational reflexes required to change the course of an event in real time. When an anomaly is detected, the system's first reflex is to prioritize. It does not treat every data spike or sensor alert with the same level of urgency. As raw data hits the decision engine, it performs high-speed calculus, weighing risk against safety, production, and cost. This immediate triage sorts every threat into prioritized categories: critical, high-impact, medium, or monitor, routing the crisis correctly. This instantaneous sorting is what prevents data fatigue. It transforms OmniPetro from a passive monitoring screen into a live command center that knows exactly where to direct its focus. The first path is designed for complexity. Scenarios that involve deep nuance, long-term strategy, or unprecedented operational variables are routed directly to human command. This layer functions as a collaborative environment where expert engineers and operations managers and emergency teams work alongside top-level executives. Here, the system provides the data, but the humans remain the final authority. They review the AI's recommendations, assess the broader context of the facility, and manually authorize the most sensitive decisions. This is the core of human-AI collaboration. The technology does not replace the expert. It provides them with the clarity and the time needed to make high-stakes judgments with confidence. But there is a second path for moments where human latency, the time it takes for a person to process information, is a danger in itself. In a sudden blowout or a pressure surge, seconds are too long to wait. In these volatile moments, OmniPetro triggers autonomous execution. This protocol is authorized to bypass human approval to ensure the immediate safety of the facility. It sends instantaneous commands to the field, isolating pipelines, relieving critical pressure, or shutting down high-risk machinery before an operator can reach the radio. This execution relies on a network of automated assets, including smart wells, industrial robotics, and remote drones that can respond to a command in milliseconds. By acting on its own logic when time is the greatest threat, the system converts digital insight into a physical defense of the operation. Once an action is taken, the cycle does not end. The system immediately begins monitoring the real-world results of its intervention to see if the threat has been neutralized. This is a continuous learning loop. Data from the physical outcome feeds back into the AI models, allowing the system to refine its logic and improve its next response. Because these choices impact global energy supplies and safety, they require absolute accountability. OmniPetro logs every single modification, every human override, and every autonomous command into an unchangeable record, ensuring total transparency for every decision made by the system. This loop of action, learning, and logging elevates the platform from a software tool into a living operational command system. What we see today is a highly coordinated dance between the speed of artificial intelligence and the experience of human oversight. But as these systems become more refined, we have to look toward the next stage of the industry, a time when these facilities don't just alert us to problems, but manage their entire operational life cycles independently. The architecture of OmniPetro is the technical foundation for that trajectory, moving energy production toward a future of fully self-regulating and self-protecting assets.